Good morning all. I am Akshara KP, second semester Iim.Tech Structural Engineering and Construction Management SNET Adur. Today I am here to discuss about the topic Design Principle of Deck Slab Bridge. Deck slab bridge. The bridge with an upper horizontal beams that carries roadway or railway is known as deck of the bridge. In deck slab bridges, the deck itself is the structural frame or the entire is thin beam acting entirely as one primary member. These types are used where the depth of the structure is critical factor. A slab deck is one where the deck is analyzed as a plate. If the slab has a different stiffness in two directions right angle to each other, the bridge is analyzed as the orthotropic deck and the bridge is known to be the deck slab bridge. Load classification. First one is IRC class AA loading or class 70R loading. Second is IRC class A loading and third one is IRC class B loading, and it is adopted for the temporary structures only. Design principle. Step 1. Calculate the permissible stress. It is as per IRC 21. Find the permissible stress. Step 2. To find the depth of the slab and effective span. Assume the thickness of the slab. The thickness may be assumed in the range of 80 mm and 90 mm. The effective span is least of clear span plus effective depth and center to center of bearing. Step 3 is the cross section of bridge. This is the picture of the cross section of bridge. Step 4 is the dead load bending moment. The dead weight of slab equal to the overall depth into density of concrete. The dead weight of bearing cord equal to width of bearing into density of bearing cord. The total load is equal to dead load of slab plus dead load of bearing. Then find the bending moment. Step 5 is the live load bending moment. Generally, the bending moment due to live load will be maximum for IRC class A track vehicle loading. As per IRC 6-2000, close to 11.3, the impact factor for IRC class A tracking vehicle is 25% for span up to 5 meter, linearly reducing to 10% for span of 9 meter. The ground contact length is 3.6 meter and the length of the vehicle is 7.2 meter. The effective length of road equal to LT plus 2 into TS plus TW, where LT is the length of trackled vehicle, that is 3.6 meter, TS is the thickness of slab and TW is the thickness of bearing cord. This is the figure representing the effective length of rod. Step 6 is the effective width of slab. As per IRC 21-2000, clause 305.16.2, B effective is equal to alpha A into 1 minus A by L0 plus B1, where BEF is the effective width of slab on which the load acts, L0 is the effective span, A is the distance of the center of gravity of the concentrated load from the nearer support, B1 is the breadth of concentration area of the load, that is dimension of the tire or track contact area over the road surface of the slab in a direction at right angles to the plan, plus twice the thickness of the bearing cord or the surface finish above the structural slab. Alpha is the constant having following values depending upon the ratio B by L0, where B is the width of the slab. The calculation of effective dispersion wheel or track load length. The dispersion of the wheel or track load may be assumed at 45 degree. To obtain the maximum bending moment, the wheel of IRC class A vehicle are symmetrically placed on the slab. The effective dispersion wheel load length equal to the length of contact plus 2 into overall depth of the slab plus bearing cord. This is the figure of the dispersion of load due to IRC class A vehicle, a longitudinal view. The tracked vehicle is placed close to curb with required minimum clearance. The total load of two tracks with impact equal to 35T plus 35T plus 1 plus IF. The average intensity of load W is equal to WTR by LR into BE, where LR is the effective length of rod and BE is the effective width of rod. The maximum bending moment due to live load equal to W LR by 2 into X minus W into LR by 2 into LR by 4, where W is the average intensity of load, LR is the effective rod length, X is the distance from center of gravity from nearer support. The total design moment equal to moment of dead load plus moment of live load. Step 7. the shear due to Class A tracker vehicle. For maximum shear and support, the IRC Class A tracker vehicle is arranged as shown. This is the load position for the maximum shear. The B effect is equal to alpha A into 1 minus A by L0 plus B1 as by IRC 21-2000 clause 305.16.2. B1 equal to 0.85 into width of wheel or track plus 2 TW, that is 0.85 plus 2 TW. 0.85 is the width of the wheel or track. Then A equal to distance from center of gravity to nearer support, and L0 is the effective span. The shear force VA is equal to W into LR into L0 minus X by L0, where LR is the effective length of rod, W is the load intensity. Dead load of the shear equal to WD into L0 by 2, where WD is equal to dead load. The total design shear is equal to shear force plus dead load shear. Step 8 is the design of deck slab. Effective depth requires D is equal to root of M by Q into B. M is equal to M dead plus M live. Provided effective depth should be checked with the required effective depth. The distribution reinforcement, the bending moment for reinforcement equal to 0.3 live load bending moment plus 0.2 dead load bending moment. Then calculate the area of distribution reinforcement and spacing. To prevent shrinkages, crack, provide supplementary reinforcement of column of diameter bars at 300 mm center to center, both at the top of slab. Step 9 is the check for shear stress. As per IRC 21-2000 clause 304.7.1.1.1, tau is equal to V by BD, where V is the design shear across the section, B is the breadth of the member, which for flange section shall be taken as the breadth of the web, and D is the effective depth of the section. Step 10 is the design of curb. As the curb is also a part of the deck slab, the vehicular load will have influence in generating bending in the curb. This bending moment is normally taken as 50% of live load bending moment obtained from the deck slab. The step 11 is the detailing of the reinforcement in deck slab. So these are the steps. Thank you.